talk about is human-computer interfaces for visual data and how we can use computers to get a better understanding and more effective interaction with visual data. And a lot of what I'll talk about this morning has to do with multi-touch technologies, digital stylus technologies. I found it really interesting in some of the opening discussions about the invention of the mouse, the invention of the keyboard. A lot of these human-computer interfaces have been invented decades ago and have served us very well. But if you look at the last several years here, there's been a real revolution in the mobile space in terms of the human-computer interface. So most of us don't have, phones with keys, a keyboard on them anymore. It served us well. There's been a real revolution on those devices, and yet for the bigger systems that we have on our desktop or maybe we use in our homes, it's pretty much still the same interfaces that we've been using since, they've been invented in the 60s and became popular in the 80s. It seems like we could probably do a lot better. Where I work at HP is in the workstation business, so we build very powerful personal systems for professionals. So our high-end workstations have 16 cores, you can put half a terabyte of RAM in these things. And what do you do with that? Well, you crunch through enormous data sets, you generate enormous amounts of information. In a lot of cases, then the question comes down to, and I mentioned it earlier, I want to see the patterns, I want to interact with the data. In a lot of cases, the human interface to the machine is not sufficient to let you do that effectively. And that's really one of the barriers that we want to try to knock down. So I'm going to talk about that a little bit this morning. Touch systems have been around for a long time. HP has done touch-smart systems for consumers, and yet they've never taken off the way that touch has taken off in mobile systems. And there's a couple reasons for that. First, the technology itself today is kind of clunky. The first generation of optically camera-based touch systems were more suited to single touch, maybe pushing buttons than actually interacting. So when we looked at, for our professional customers, engineers, scientists, the animators, the folks that we sell to a lot, we said, well, what do they need to really understand their data and interact with it and sort of get the computer out of the way? And there's really three components I'll talk about. The first is the multi-touch capability itself. You need to have unlimited number of touches. It needs to be a very responsive system, and it has to be very precise. The second component to this is a stylus. I enjoyed the pictures of Ivan Sutherland way back in the day, inventing the very first stylus. Your fingers, touch is great for manipulating things, or if you want to navigate around on a map or move objects. I'll show some videos in a minute of that. But if you're doing precision work, if you want to create information, if you want to do precision selection of information, then your finger's too much of a blunt instrument. You need something much more precise. And usually the weapon of choice there is a pen. This has to have even more resolution, sub-pixel resolution. And you want to really emulate things that you're used to using with pencils and pens, things like pressure sensitivity. If I'm drawing, when I push harder, the line maybe should get fatter, etc. It also has a lot of indirect impacts on the design of the system and the ergonomics. It's very difficult to work all day with your arm up like this with a traditional vertical display. You need to have something, the picture I've shown here, you need to have something that lays down and is more comfortable. It has a lot of indirect design implications as well. You want to have a flush glass surface, right? I'm going to lay my arm down, say, to draw on it. I don't want to be banging my hand into the edge of the display. You need to have something called very low parallax. If you've ever, noticed when you sign your name at Target or whatever, the credit card's it's usually a really sucky experience, right? It stinks. It's one of the reasons for that is a huge gap between the surface of the glass and where the image is actually being drawn. So you're very disconnected from that. So for these systems to be effective, what we're really striving for is we want you to feel like you're touching the object on the screen. If you're reaching out to manipulate it with touch, if you're drawing on it with a pen, it needs to feel like you're actually touching what you're seeing and not, you can't have a big gap. And then the last element, and this is where I think the magic happens, is combining touch and pen. So there have been touch systems out there. There have been pen systems out there. There are today. But we think the thing that people have missed and what has not been done before is putting these things together. It's a very natural human interaction, going back to the Neanderthals, of having a tool in your right hand, if you're right-handed, or your left hand, if you're left-handed, and using your non-dominant hand to basically manipulate the object, whether you're a sculptor or you're writing, or whatever you're doing. That's a very natural thing to do, and lets you then focus on your work rather than reaching over and doing this. So the picture I've actually shown here is not a touch and pen system. It's showing how people do this. It's actually an animator, one of our friends at DreamWorks Animation out in California. And this is showing typical pen-based systems today. So he's drawing, probably a picture of Shrek or something there. He's got the pen in his right hand, he's got his left hand over on the keyboard, he's doing hotkeys to manipulate the object or run the user interface. He's got another display off to his right for his email or web browsing, things like that. So that's what we're trying to get away from, is that kind of awkward interaction. I'll show a video in a minute sort of showing what we would like to go to. So again, the idea is that you can focus not on the user interface and a bunch of pop-up menus and navigating through things with a mouse, but you're actually reaching out directly, manipulating your data, keeping your focus on what you're working on. IBM did some really great research way back decades ago on on productivity and how damaging it is to even have sub-second, even multiple millisecond interruptions in your flow. Really disrupt what you're doing. The longer you can sort of stay in the zone, if you will, focused on the content and what you're working on, and not have the distractions of going over to pop up a menu or change something, that all gets out of your flow. So let me first do a couple of videos and better illustrate what I'm talking about. So this is a multi-touch interface for 3D data, and you can see here this is not just using a single finger to move something or doing a pinch zoom like you would. It's actually more complex than that, using both hands and using multiple fingers to basically be able to reach out and manipulate 3D data in this case. This is Brian Matthews at Autodesk did this video at Autodesk University a few years ago, and that was really good. They basically took one of the Autodesk 3D applications and modified it to use a multi-touch wall. So this is a good example of just using touch, but I think it really all comes together with this video where you see the idea, the concept. In this case, this is just a simple 2D system. It's just a simple PDF markup tool. It's really just a demo. But again, the idea here is that you've got the pen in the right hand to do, in this case, fairly crude markups, but you certainly do something more sophisticated, and then a very natural interaction with the left hand to reach out, in this case, grab, sift through the data in a very visual, natural way, grab the document you're interested in, and if you've played with this, and I was showing a demo of this later this afternoon, you can try it out for yourself. It very quickly becomes a very natural thing. You forget, matter of fact, when I use this, I find myself holding the paper down with my left hand, even though I don't need to. That's just what I'm used to doing, right? I hold the paper down while I write on it, and then I move it away and I bring in another one. The ability to easily zoom in on the data, look at what you're working on, focus on what you're interested in at the moment is a very powerful thing. And then when you're done, it's very simple, very easy to move out, to move back and get back into more of a macro view of the documents you're working on. One of the companies we've worked with, an independent software vendor in the oil and gas exploration field, is implementing their applications with this. In their case, they have geologists that look at mountains and mountains of seismic data, looking for fissures in the bedrock, looking for the areas where likely there might be oil pools, good places to drill. As you can imagine, they spend a lot of money to try to be accurate in their prediction. They had a tool where they would go through data like this, and then their geologists would mark it up, looking for the interesting areas. It took them about 40 clicks nearly to move from one piece of data to another. They say, I marked this up, and I want to go to the next one. Well, I got to go pop up this menu, and I got to open this, and I got to do that, and then go to this menu. They estimated by going to an interface like this, they were getting about a 40% productivity gain for their scientists, and for them, that's huge. Okay. So I'll talk very briefly just a little bit about some of the underlying technologies behind this. One of the key things is a technology called projected capacitive touch. If you've got a smartphone, if you've got an iPad or a tablet, you're using this now. This has been very popular and very effective in mobile devices, but up to now it's been much too expensive to do in the desktop system and a large system. That's changing rapidly, and that's kind of what's driving a lot of this revolution. This system that I showed in the video is still very expensive today. That's a, you know, as you see it, that's maybe a $10,000 system. It's coming down quickly. Things like Windows 8 will drive that down. The new specs for Windows 8 pretty much will drive most of the industry to this kind of technology over time. So as that becomes economically viable, I think you'll see this in more and more systems. And the capabilities for it are really great. If you've had the experience on a smartphone, then you know what I'm talking about. So it's really what we want to try to do at HP, is try to lead the way into, basically I want to have a 27-inch iPad. Some other interesting things you can do with this, and some research is going on right now. The touch sensors for these things don't have to stop at the visible boundaries of the screen. You can extend that touch sensor out into the black space, if you will, out into the bezel. This is a video that just demonstrates some ideas. Why would you want to do that? Well, in the quest for keeping your attention focused on your content, it's nice to get all the rest of the stuff out of the way. You lose a lot of screen real estate today to menu bars and the bars on your browser or whatever, and stuff down the sides, all of that stuff, you know, it's great to have it. It needs to be readily available, but you really don't need to be looking at it while you're working on, you know, your content. So the idea of the bezel sensing that is that you could say put user interface elements or you know, soft keyboard or the data set that you're working on in your document library or in your part library, you know, off screen, but in an area that you could do an easy swipe to get access to that. So let me end with, as I said, I'd get back to this. First of all, I'm going to do a demo this afternoon, so during the dessert session, I'll have the system that, the touch and pen system you saw in the video, I'll have one of those here running that application, that demo, so you can come play with it. You know, picture's worth 1,000 words, a video's worth 1,000 pictures, and a demo's worth 1,000 videos, so I encourage you to stop by if you can. And second, I'll blatantly, you know, advertise I'm looking for an intern to help with this. So I'm here in HP, Fort Collins. I had a great CSU intern, Crystal Redmond, worked for me for about 3.5 years. She's a grad student in the CS department. She's going to go focus on her PhD now. Probably a good thing to do. So I'm looking for somebody to help with this. I'm looking for somebody who can do touch software development and help us experiment with this and evaluate it. So come and see me this afternoon if you might be interested. And I guess we'll save the questions for the session.